All right, this is lesson 4.3, and it is solving a quadratic by factoring. So if you don't have factoring down, you need to practice, and you are not going to be able to grasp this lesson very quickly if you don't have factoring mastered. So you need to be practicing daily and passing those mastery quizzes because factoring is very important. So let's go ahead and review foiling. We've got first, outer, inner, last that we're multiplying here. So it's 3x times x or 3x squared. It's 3x times negative 1 or negative 3x. 2 times x is 2x. And 2 times negative 1 is negative 2. And then combine your like terms to get your final answer. All right, you try number 2. Pause, FOIL, then check when you're ready. Should have gotten x squared minus 4x minus 12 after you FOIL. First, outer, inner, last. Then combine like terms. All right, so factoring. Always start with pulling out the greatest common factor. So 9, 15, and 4, there's nothing I could pull out of each of those. So I have a number in front, which means I'm going to take my first term times my last term. And I'm going to come up with the factors of 36 to replace the 15m with. So think about the factors of 36 that add to get 15, and that would be 12 and 3. So I'm going to keep my first term, keep my last term, and replace the middle, which we call splitting the middle. So splitting that middle, that 15 into a 12 and a 3m, which is the same thing. It still adds up to 15. Now I can go ahead and grouping those first two, dividing out the greatest common factor, which is a 3m. So I'm left with a 3m plus 4. And then over here, I can't pull anything out, so I just hold that place value with a 1. Notice the parentheses match. That's how we know we did it correct. And put those greatest common factors together, 3m and the 1. And then what they have in common. So 3m plus 4. And that's it. Number 2, looking to see if there's anything we can divide out. Nope, no greatest common factor. And there's a 1, so 1 times 16 is 16. And what are the factors of 16 that add to get 10? So we think of those factors, and it would be 8 and 2. And we can just go ahead and have x and x as our beginning terms there, because x times x gives me x squared. And the last two are those numbers that multiply to get 16, 2, and 8. But remember, they have to add to get the middle term, and we're done factoring for that one. So when solving quadratic equations, you will be asked to find the zeros of a function. So what does this mean? A zero of a function is a value of x which produces an output of 0. So produces an output of 0. So if I am at the point where the graph crosses the x-axis, then what's the value of y? Well, it's 0. It's that output of 0. So our x is the answer, the solution. So solutions are where it's equal to 0. There are usually 2 solutions, as we have seen before from our last lesson, and they are called also the roots, which we've seen before. So roots, zeros, solutions, kind of the same thing. So if the product of 2 quantities equals 0, at least one of the quantities then is 0. So if it's a times b equals 0, then either a or b could be 0, because that's how we get 0 when we multiply. At least one of them is 0. So let's go ahead and practice. Again, factoring, have to have that mastered for it to help you in this lesson, for you to be able to get it, because we have to factor. So we're going to set it equal to 0 first. Why do we do this? Well, we're finding the zeros, remember? So that's why we set this equation equal to 0, to make that output 0 to find what the x value is, or the roots, or the zeros. So our first step is going to be to factor. So since this is an x squared, you should realize that you're going to have that shortcut method of x and x, and what are the factors of 12 that add to get negative 8, which would be negative 6 and negative 2. Negative and negative would multiply to get positive, but add to get negative 8. So we have those set equal to 0. Now we're going to apply the zero product property, meaning we set both of them equal to 0. Does that mean one or both could be equal to 0? And then we solve. So here I would just add 6 to both sides, and x equals 6. Here I would add 2 to both sides, so x equals 2. And then we can check using the calculator. Remember how we plugged that into the y equals and we hit second graph and we looked at the table of values? And then we would look to see when our y value was 0, and we would look to see, and we'd have 2 over here, and 6 would give you an output of 0 as well. And so we could check using the calculator. But you can't always rely on that calculator because you do need to know how to factor, because that is this method for this lesson, is being able to solve by factoring. So let's try the next one. You can try it on your own and pause me, or you can follow along if you still need to see another. So set it equal to 0. And then we're going to factor it. So what can I pull out of each of these? Remember to start with that greatest common factor. So 3x, so I have an x plus 4. Can I factor any more? No, this is as factors as possible. This is just an x, not an x squared, and this is not a minus, so there's no difference of squares there. So we set each of those parts equal to 0, and then we solve for x. So divide by 3, so x equals 0. And then over here, subtract 4, so x equals negative 4. And then again, check using your calculator by typing that into y equals and hitting second graph. All right, so let's take a look at a couple more examples. So I want you to try these on your own. Remember to pull out the greatest common factor first, and then factor. You might need to do this on a separate sheet of paper or off to the side for a little more room. But look for, this one is going to be 3x plus 2 times 3x plus 2. Perfect square trinomial for this one because it's a 9 and a 4, and they would multiply to add to get that 12. So it's 3x plus 2 squared, or you can have them both written next to each other. So when we set those equal to 0 and solve, we'll get the same answer. Subtract 2, divide by 3, you'd get negative 2/3 as your x value. And then on the next one, again, pause this one, set up your 2 parentheses. So pause and try it on your own. What are the factors of 8 that add to get negative 6, and then set them each equal to 0 and solve. And hopefully you came up with negative 4 and negative 2 to go inside your parentheses there, and you would end up with x equals 4 and x equals 2 as your roots or zeros. So the roots, the values of the variable that make the equation true. So it's the same method of finding zeros, which is kind of why we say them all in the same way, but you're going to factor. So factor just like we did above, because it's already equal to 0. We can then take our factors, x squared, no number in front, so x and x, factors of negative 12 that add to get negative 4 put there, set them each equal to 0, solve for your x's. So try that one on your own, pausing. All right, let's check. It should be negative 6 and positive 2, and then we set them each equal to 0. And then we add 6, and then we subtract 2, so you should have x equals 6 and x equals negative 2. Over here, we want to make sure everything is equal to 0 before we get started, so subtract your 48x, add your 32, and do that to both sides, and you would have it equal to 0. All right, so next we're going to look for that common factor. Pull out that greatest common factor out of 32, 18, and 4, and that would be at least 2. I have this one written, so let's pull a 2 out and see where that gets us. 9x squared minus 24x plus 16. There we go. And look to see, I see a perfect square here and a perfect square here. So let's see if it's a perfect square trinomial. So this would be a 3x and a 3x to get the 9x, and then the factors of 16, which, again, perfect square, so 4 and 4, so 12 and 12, yep, would add to get that, and it would be subtraction here. And then we would set each part equal to 0, so we would wind up with 3x plus 4 equals 0, oops, minus 4. And then we'd add 4, and we get 3x equals 4, divide by 3. So x equals 4/3 for this one. So factoring, have to have it mastered. So begin practicing using those factoring packet and the notes packet, and then as well as the factoring review packet as practice. All right, we're going to go the other direction this time. So we are going to put them back in. So let's say we have x equals 2 and we have x equals -1. So we're going to put them back into the equal to 0 kind of thing. So subtract 2, we kind of do the opposite. So it's x minus 2 equals 0. And then over here, add 1, x plus 1 equals 0. So we're going the other direction now. So putting them back into the parentheses before we set them both equal to 0. And now we can go ahead and FOIL. And then we can combine like terms and put our f of x equal to our original quadratic expression. Oops, forgot the, yeah, that's right. Add those together. There we go. All right, so remember to do the opposite to get them first, set them equal to x, then get them equal to 0, kind of undo. So we are going to add 2, so it's x plus 2. And then over here, undo the division by multiplying by 3 first. Now undo this 1 by subtracting. So in our parentheses, we have an x plus 2, and we have a 3x minus 1. We're now going to FOIL. So 3x squared plus 6x minus x. When we FOIL it, you can put your lines if you need to. Combine like terms. And we are going to, oops. So 6 and, let's see, 6 and should be -1. There we go. Yep. And we have f of x. Okay. So try these last few on your own, and then I'll stick the answers up there for you to check. So you need to practice putting them back into, and it's kind of the opposite. See how up here we had x equals -2 and we put it back in? It's kind of that opposite thinking. Be careful with the fractions, as you want to undo that division first and then subtract or add that last number. I don't think we have any like this. So hit pause, try those on your own, and then you can check. So if we have x equals 6 and x equals -2, putting those, getting them back to on the other side would be subtraction, so -6, and would be addition, so +2, and then FOIL. So you should have x squared and 4x minus 12 for f of x equaling. Over here it would be -4 and -2, and FOIL, you get x squared minus 6x plus 8. And then the last ones here, x plus 4 and x plus 9. So x squared plus 36x plus 36. Nope, that's not right. This should be 13. I can add sometimes. All right, and then over here, so it's x equals 7 and it's x equals 0. So this one would be an x minus 7. This one would just be an x because it already equals 0, so it is just x. So now distribute, because there's no real foiling there, and you would get your final